Welcome. In this video segment, we're going to model ionic compounds using Lewis dot structures. Typically, Lewis dot structures are a little bit more valuable than for covalent molecules than they are for ionic, but they still really help us understand the charges of our ions. So what we're going to do is I would recommend always starting with the atom. Tin, and I'm going to draw this a little bit bigger down here, I think it'll help out. Tin has 4 valence electrons, and we're going to follow Hund's rule. I personally don't care where you start, but listen to your professor or your teacher carefully because some people are picky about this. I'm going to do Hund's rule. 1, 2, 3, 4. Some teachers like to envision these as S and P orbitals. I don't do that. So tin can lose 2. So tin has 2 S's and it has 2 P electrons. So if tin lost its 2 S electrons, if it lost 2 electrons, it still has 2 remaining. And then if it's an ion, we always put brackets and charges. Okay? Now, tin with its 4 electrons could also lose all 4 of those electrons. It would have no more valence electrons left, and it would have a 4+ charge. So I think IBC root beer. Ions use brackets and charges, and the charge goes just outside those brackets. So let's work a handful of these and see if I can help you understand them a little bit better. So if I have lithium, that's lithium element. It has 1 valence electron. If it lost that valence electron, it would be just like the previous noble gas. And so I'm going to lose that 1 electron to form the lithium ion. So that's why you see group 1 is always +1 because it loses that singular valence electron. So this is boron. It has 3. Now, I'm not making the boride ion. Negative ions end in IDE. This is just the boron. So I'm going to assume that we're losing 3 electrons here. If I lose 3 electrons, so from here to here, I've lost 3 electrons, it's less negative. It's positive. Oxygen has 6 valence electrons. 1, 2. Watch what I'm doing. I'm going to go around and do them unpaired before I pair them. Again, pay close attention to what your particular instructor does. Now, oxygen's a nonmetal. Nonmetals are winners. If oxygen simply gained 2 electrons, it would become the oxide ion, and instead of having 6, I would have a stable octet. Now, the stable octet's very clear with oxygen. It's less clear with the noble gases. Lithium actually is like helium, which is a noble gas but with only 2 electrons. The other noble gases all have 8 valence electrons. So the metals that tend to lose to become like the previous noble gas, so metals lose to be the previous noble gas, they have an octet. Nonmetals add until they get to the next noble gas, and then they have a stable octet. Okay? Now, bismuth has 5 valence electrons. It's group 15. It has 5 valence electrons. Now, this time I have to indicate somehow which ion I want. And the question asks for the +3. That's less negative, so I'm going to lose 3 electrons. Of course, it's going to lose its paired one first. So 1, if it loses 3, it's going to have 2 left. And then a 3+ charge. Okay, just a few more, and I think this will be, clear for you. And then we'll see how we make formula units with these ions. So antimony is a metalloid, and it has 5 valence electrons. It can actually gain or lose, and so its Lewis dot is 1. Envision a square, if you would, around the element. Don't draw the square, but you can envision a square around the symbol, like that. Okay, and antimony has 5. To become the +5, it's going to lose all 5. +5 is less negative, so you're going to lose 5 electrons. It's an ion, so you must indicate that with brackets and a charge. Phosphorus is a nonmetal. It has 5 valence electrons. To become the phosphide ion, "ide" means anion. So "ide" for ions means it's going to become a negative ion. It can gain 3 electrons. So if maybe I can change colors and make that a little clearer. It had 5. If it gains 3, do you see now it has that stable octet? Don't forget your brackets and your charge. It's correct to put the number before the sign. I don't know many teachers who would take points off if you put the sign before the number, but the number before the sign does a much better job of setting off that negative and that positive charge. Iodine is group 17. It has 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. If it gains simply 1 more electron, it will have a stable octet and become the iodide anion. Xenon doesn't form ions. I just wanted to show you it's group 18. It has 8 valence electrons around it. And then helium is only got 2 electrons. It doesn't reach a stable octet. It's too small. Small ones typically don't reach an octet. So, okay, hope this helped. In my next video, I'll be showing how we can combine these cations and anions to form neutral formula units. Thanks for joining me.